Okay, welcome everybody. Uh, yeah, yeah. My name is James. I'm going to be your instructor for today. Bruce will be back probably next time. So this is just a temporary situation. If you haven't signed it already, I believe the sheet is going around for the attendance sheet. If you could sign that, that'd be very helpful to us. So with that in mind, let's get right into the material. Last time, you guys had covered functions, if statements, and a bunch of other control settings. And we learned how to do data frames, amongst other things, which is great. But what happens if you want to take that data and instead of looking at it in a method, in a format that is just text-based, you would rather like to see it graphically? Because, I mean, let's face it, if you look at text-based things all day, you're certainly going to get either very bored or it's not going to be giving you enough information. And that is what we're going to learn today. We're going to learn about plotnine, which is part of the PlotLib package, Python package. And what this allows you to do is it allows you to show your data graphically. So with that in mind, if we could just get over here. By the way, please bear with me. I'm not a Mac guy. I'm learning this as we go. So if I am struggling to get the mouse where it needs to go, just give me a moment and it'll get there eventually. So let's go ahead and start with the code. So we're going to type in matplotlib. Oh, if I can type today. Hold on. And this is just an import statement, as we learned before. So you're going to import the library. And then we're also going to import plotnine as P9. And this is just the alias. I'm sure you guys are all familiar with this already. This will just allow us to use P9 instead of the word plotnine, which saves us a lot of typing over time. So we're going to go ahead and run that import statement. Next, we're going to import pandas. As you guys are probably very, very well aware of what pandas is by now. Oh, that's not how you spell pandas. All right. And once again, we're going to create our data frame. So we're going to type surveys. This time we'll do it as surveys complete. And we're going to make it equal to a panda data frame while we read in the CSV. And I'm sure you guys all know this part by now. The data/surveys.csv. Oh, that is absolutely not how you spell surveys. Okay. And we're going to then take the surveys complete. And I believe this is something that you guys learned last time, which is to drop all data in your data frame that does not have like the not a numbers. You guys remember that, like the null values? So we're going to go ahead and say surveys complete dot drop na. And if we run that, we're going to get an error, apparently, because I probably have a typo right there. What's that, sorry? Thank you. I'm working with a keyboard that I'm not familiar with, so please. Oh.
Drop NA has an underscore as well.
Sorry about that. Drop NA, no, drop na should be fine. Oh, always technical errors, eh? Data/surveys.csv does not exist. Bruce, your surveys.csv doesn't exist?
It's not in the data folder.
Where is it?
It's just in the root folder. Just get rid of
So
data.
surveys.data? Okay, surveys.csv. That would be helpful. Okay. So I'm actually using his computer. So I apologize for that. All right. So what we've done is we've created now a data frame, as you guys have been doing all along, and I'm sure that you're aware of how to do that. Oh, sorry, I completely forgot. If you guys have an issue, as you already know probably, go ahead and put the yellow post-it note on your laptop, and someone from over here will be around to assist you. If everything's good, you guys can keep the green one there or just have none at all. So we are going to use something called ggplot. And in order to do that, we're going to create p9, p9.ggplot data equals, and I'm going to explain this in just a moment, surveys complete. So there are three major components to the ggplot function that we're going to use today. There is the data, the aesthetics, and the geomes. And I'm going to talk about each of those individually. But the entirety of this lesson is going to be revolving around just those three things. And you'll see how easy it is to manipulate this in a moment. So we're going to go ahead and hit enter there. We've created a plot right there. And next, we are going to, yes?
Is anyone else having trouble with the plotnine import statement?
Oh, yes. That's a good point.
Yeah, so it might not have been part of the default combat itself, so I'm going to come around and help you guys.
You probably have to install it. Yes. Oh, yes. So please, don't be shy. Use your yellow post-it note if you're having a problem. When I set this up yesterday, I did spend about 15 minutes trying to get the import statements to work, so don't be ashamed. It's totally normal. Computers work sometimes. Is everybody else? Looks like most people are probably good to go, so we'll give it a quick moment and then we'll continue. So, yes, absolutely. Right there, that one there? Keep going? Okay, sure, yeah. That's no problem. We'll go up here. I'll just give you the whole thing. We're going to take just a short break because I think there's 2 or 3 people that are having problems actually getting their import statements. So just hang tight. You have to pip install. Yeah.
So we also get new map PlotLib, new pandas, along it. So now
Wow.
you point to your notebook, and we'll be right back to report.
Excuse me. I'm just going to go assist some people. Is anybody else having issues?
Go to your
Everybody's good?
if you navigate to the folders.
How you doing, man? You guys are good? So far, so good? Excellent. Yeah, absolutely. Hold up a second. Come around here.
The other also worked because we had where we were working and a separate folder with data, where all the data, while importing directly when we were working with survey,
Right.
might lead some errors, just in case some others.
Well,
We have a subfolder with data.
Yeah, and on that computer, there is no subfolder with data on it, and that's why
Maybe it's just
I
not
changed
working.
mine. Is yours working fine?
Yeah, but
Okay.
I just have to work in data.
To the data,
it's
because there's a
kind of different
subfolder.
work. Yeah.
Yeah, and that's totally fine.
That's
That
not
won't
really
change
the
anything.
others. Yeah, for sure.
Yep.
It was just
Oh,
saying that
that's true. The other
might
people
be
might have
not
that.
notice why the error is that.
That is true.
In case the error
We're just talking. She was talking about the subfolder of data. Some people have it and some people don't,
Right,
and that's
yes.
causing an error too.
something to make a subfolder.
Yeah.
I'm not sure.
You only get
John? Yeah, that's a good point. We'll make sure to
Thanks.
tell people that. So actually, So while they're getting set up, just to kind of continue with what I was saying, and this is less of a lesson and more of just a paradigm to understand what we're talking about. You'll notice at the bottom of the lesson plan, you'll say the key points are data, S, and geometry, and those are the three things I was speaking about. So there are only three things we're really working with today, regardless of how complicated this might seem as we move along, and no matter how many things I throw at you, they're only going to fall again into one of these two categories, the data, aesthetics, geometry, or a plus operator. So as we move forward, I'm just kind of giving you some background information. Just remember that we're really only working with two things in this entire lesson, and it may seem, I'm just giving some background information while he gets going. Yep, okay. So, am I quiet? Okay. Turn me up a little.
Yep. There we go.
Can you guys hear me now in the back? Oh, wow. All right, it's nice to hear my own echo. So yeah, we're going to be working only exclusively with these two things, and once we get into the thick of things, even as I was going through the lesson myself, I noticed that there was a fair bit of complicated functions that you might come across, but when you look at them within the paradigm of just those two things, it becomes much simpler. Okay, am I too high now? Well, there's nothing to go. I'm waiting for them to finish up. Just giving them some information. Okay. All right. So, I think we can probably go ahead and continue on, if you guys don't mind. So what we've done here is we've created a P9 ggplot. So P9 being the plotnine, right, as we imported it, as I'm sure you guys are aware. The ggplot is the new component that we're working with, and this is a part of the package that allows for graphical representation of your data. So charts, bar charts, plot charts, whatever it is that you want to do, and there's a whole bunch of them that you can work with. So what we've done so far is we've given the data that we would like to see plotted or graphed, right? So this is the data is equal to the surveys complete that we just made up top here. So we're going to go down, and next we're going to give the function. Let me just go ahead and take a peek here. Okay. Again, I'm working with a laptop I'm not familiar with. I apologize. So p9.ggplot. Again, we're telling it we want to work with ggplot. We're going to say our data is equal to. Oh, that is caps locks. Our data. Come on now. Is equal to the surveys complete, because it needs to know which one, which set of data it's going to be working with, and we've been working with this data all along, so that's not surprising to you. I'm just going to do this for aesthetic purposes. You don't have to enter here if you don't want to. It could be all on one line. That's no problem. Next, we're going to give it a mapping, and that is going to equal p9.aes, and this is short for aesthetics, by the way. So if you ever wonder what the AES is for, that's what it's for. And as with any graph in the history of mankind, we're going to give it a mapping of an x value, and let's call that weight. And we're also going to give it a y-axis, which is, I don't know, let's call it hind foot length. All right, and then we're going to go ahead and run this, and you're going to get a nice non-existent chart. Why is your data not available? What's that, sorry? It did not load. Read CSV, surveys.csv. I'm just dropping the null values. So this should have appeared too, this ggplot here.
Yeah?
Yes, of course. So that is there.
I have not had this happen before.
Neither did I.
Apologies, everybody. Technical difficulty here.
Our computer's the best. Sure.
Here's the one that I read.
Yeah.
PD that.
In the plot that you make.
Excellent. Thank you very much. Appreciate that.
Thanks for your patience, everybody. Sorry about that.
Sorry about the technical difficulties. All right, so again, coming back to the original point that I had made at the beginning of all of this, there are three major components that we're working with that are divided into two sections. The first is your data right here. We've given it surveys complete. It's a data frame, as you guys have worked with before. The second one is your mapping, which is going to be your x-axes, your y-axes, and changing anything that has to do with those, and we'll get into that in a moment. And then, of course, your third point is going to be your geometry. So what kind of graph do you want? What kind of representation graphically do you want to see? In this case, we're using the plotnine geometry of a point. So every single one of these is a point of data that all 332 rows of data that we had. So as you can see, this is probably a lot nicer to look at than 332 separate rows as you're scrolling down on your computer, right? This actually gives you some substance, some actual substance to look at and to evaluate what your data is saying to you. But this doesn't really mean a whole lot, because this is just a bunch of points on a graph, and if that's what you're looking for, that's great. But if that's not what you're looking for, and if you need something more specific, there's a whole bunch of ways that we can modify this plot rather, to create a graphic representation of the data that we are looking for. So let me just go ahead and pull this up real quick. Excuse me. So I'm going to show you real quickly what it is that we did. So we have done this part right here. We have created the mapping and the data of the plot, and then we have actually drawn the plot itself. And those are the two components that I was telling you about. This is the top of that of those key points, and this is the second one of those key points where you're adding the geometry. So let's go ahead and go back to our code. All right. Going to have a very quick challenge for you. Now that you understand a little bit about it, we're going to do a very simple one. And it's going to be working on the Surveys Complete data frame. You want to use that plot ID column. You remember back when we were working with our data frames, there was the plot IDs. You want to create a bar plot that counts the number of records for each plot. So if you guys want to give that a shot, I'm actually going to give you, I'm going to show you what it looks like so that you can kind of know if you've succeeded or not. Just pull it down like that, yeah. So this is the answer that you're looking for. If you guys want to give that a shot, I'll give you just a couple of minutes to try it. It's a very simple change.
So we have a couple folks looking to catch up a bit.
Yeah, do you want me to assist them while they're doing this challenge?
What I'm going to try to do is put both of these things on the screen at once for you.
Okay, do it up. I'll go help them out. Who's trying to catch up because of technical difficulties? Okay, looks like most people are caught up and have had a chance to attempt the challenge. Oh, interesting. Okay, so is there anybody that have any answers? Did any of you guys succeed in getting that bar plot to look and feel that way? Anybody at all? No? All right, that's fine. I'm just going to drop down the answer real quick, and I'll show you what it was that you were to do. So the ggplot and the data is going to stay the same because we're always working with the same data set, so that, of course, makes sense. The mapping, however, is going to change slightly by only giving it an x value of the plot ID, right? So that your x-axis is plot ID and your y-axis is, you're not telling it what it is, so the program is going to automatically assume it's count. So I'm just counting the things that are on the x-axis. And then a very simple switch here for the geometry. We're going to turn it into a bar graph instead of a point plot. So those are the two things, and that will yield this beautiful looking plot ID bar graph right here. Okay? Is there any questions on that? Does that kind of make sense so far? Okay, fantastic.
I'm going to repair your screen now.
What's that? Sorry, yes, please. Someday I will learn to use Mac, but that day is not today. Yeah, there we go. Perfect. Fantastic. All right, let's go ahead and continue on. And I believe when it comes to this subject, the more that you do, the easier it's going to get. You're going to start to understand the nuances that are found in ggplot. So we're going to next work on, let's go ahead and scroll down here. So now that we've created a simple plot, as I told you before, that might be helpful in some ways, but it's definitely not the best version of this representation of this data that we can get. So we're going to, what if you wanted to see this plot, but not in every single point having maximum transparency? So let's say you needed to know where the clusters were the strongest. In that scenario, you could easily modify this to put in an alpha of anything you want. So let's say 0.1. And if you run this again, once it does its thing, you can see that now each point has its own magnitude, its own transparency. But because there are so many of them in a particular area, it tends to show different sets of clusters. So there's a big cluster right here, and here, and here, whereas there's kind of a scattering of data all across here. And this is a really nice way of seeing that same data that we put in earlier, but in a different way. That might be helpful to draw some conclusions from. So that is alpha. You can change that to any number at all. If you want to change it to 0.5, then it'll just be a slightly larger transparency. Same thing. Now, what if you are not black and white inclined? What if you prefer your color? As human brains like color, we can easily add a color tag. So let's just say blue and run that. And these are very simple changes, but they can certainly help a lot. So now we've got this very pretty blue color, and we've got the transparency set to 0.1, and all of a sudden our graph is starting to look a little bit better and less boring. And certainly it gives you more information as well as than just a black and white full transparency plot points. So let's say, for instance, we wanted, let's go ahead and just start a new one altogether right here. Let's practice writing it. So p9.ggplot. And then we're going to give it our data, which is, of course, our surveys complete. And then we're going to give it, I'm just going to do this for my own sanity. We're going to give it a mapping. That's not how you spell mapping. And that is equal to a plotnine or p9.aesthetics, AES. The x value is going to be our weight, again. And let's say, x value is going to be our weight. Our y value is going to be, once again, we'll just say hind foot length. And now we've already got that data up there in a nice, beautiful blue with a great transparency, and we're getting excellent information out of it. But what happens if we wanted to know, so this is all of our species, right? So this is all, let's say 23 or 24 species that we have, taking all of that data and putting it on the weight as the x-axis and the hind foot length as the y-axis, and that might tell us something interesting, but that's not always what we're looking for as a researcher. Sometimes you need to know certain things that separate your data. As an example, let's go ahead and set different colors to every single species that we have in our data. So something like that. Let's put another one here. I think I need another one of those. And then let's go ahead and give it a geometry, because it needs to know how to actually plot this data. Geom. Let's make it a point again, and we'll just set the alpha of that equal to 0.1. The same thing as we did earlier, which is we're now going to get a plot with each individual point being slightly less slightly more transparent rather. And then if there are clusters, we'll see them. Except in this scenario, instead of all of the data combined, we're going to get a syntax error apparently, chart that now identifies all of our species with a legend here on the side in different colors, and we can still see the clusters of that, which let's face it, this is very valuable information in comparison to the previous plots that we've been looking at. So as we're adding more things to this plotnine, to this ggplot, we are in fact garnering more and more data from just the 332 rows that we had. And of course, we all know that graphical representations certainly do make this a lot easier to visualize. So you might expect that that's pretty helpful for knowing which species have, which species based on which weight have different hind foot lengths. And you can absolutely use that to draw out more data, as opposed to, again, just a textual representation. So next is a pretty simple thing to do in terms of what we do on a daily basis when it comes to research, which is, if you take a peek at this weight, what does that actually mean to you? As a researcher, if you use the word weight, you'll probably be a little bit embarrassed to just use that as is, because how are you measuring weight? Are you measuring it in kilograms? Are you measuring it in grams? Are you measuring it in what kind of system? So what we're going to do is we're going to change the names of the actual axes. And in order to do that, we're going to add another plus here. I'm just going to go ahead and make that uniform for my own sake. So this is X label, or X lab, okay? And we're going to name this X axis weight, but instead we're going to put grams. So now everybody that reads our information, including ourselves, will know that this information represents weight in grams. And of course, you could do the same thing if you wanted to with hind length in either centimeters, inches, whatever it is that you've measured it in. But for now, we'll stick with just the one change, just to show you that it can in fact be changed. Oh, what did I do wrong here? Oh, right, of course. P9, my apologies. And you can see the data is exactly the same, colored by species. Y-axis is hind foot length, but now we have effectively renamed our x-axes to give us more information and to give our readers more information, of course, as well. All right, so these are all very nice things that you can do. Now, what happens if you would like to not just represent the data as is, but let's say you want to scale it. Let's say your data set is so huge that you need to scale it down. Well, that is also possible, and you know what? I'm just going to go ahead and use the same thing here, since we're just adding on. As you probably noticed, we're adding on these geometry points, and that's what I was saying. Your first part is your data, your mapping, which is your aesthetics, followed by the third part, or the second part rather, which is all of your geometry. So let's go ahead and put P9 again, dot scale, and there are many of these. These are not just, this is just one of them as one of the examples. You can certainly look to find more as you need them. Let's say scale of the x-axis log 10, and we'll see what that gives us. So now we have rescaled our graph to a log 10 base, and as you can see, it looks very different. But this is something that might be very helpful with a very large data set, something that you need to scale down, or if you just need to see it in a different way. So let's go ahead and keep going. By the way, are there any questions so far? I think you guys are all coming along so far so good. Yeah? Okay, good. All right. Now, we're going to work on the next thing, which is, now that we've got our x-axis labeled, we could also add a y-axis in there, that's no problem. We've got our transparency set completely differently, we've got it scaled. So now we're kind of working with general prettying up, for a lack of a better word, of the graph itself. And as you know, visualization is very important, so we're going to add a theme to it. And there are all sorts of themes that you can get. There's a site, I believe, I had it ready on my other laptop, but we had to switch for other purposes. But there are a number, there are dozens and dozens, maybe even hundreds of themes, and they're just preset values to change the look of your actual graph. So this is just one random theme that I took, BW. I don't know what it stands for, maybe black and white, I don't know. But we'll add the theme, and then we'll actually at the same time, let's go ahead and run that and see what that does. And then we'll add on some more beautification of our graph. So as you can see, the species legend right here is substantially bigger. It was much smaller before, so it might be easier on the eyes to see the color legend here. I believe the words are also a little bit bigger, if I'm not mistaken. And then you can keep adding to your themes by adding in other themes. So let's go ahead and change the theme. Text is equal to, so the actual text of the graph, we're gonna modify that in some way to make it more visually appealing to us. The element text, and let's change it to size 16. And we'll see what that does. All right, now I don't know about you, but I wear some pretty strong glasses, and there's a reason why I do. So this is much more visually appealing to me, to be able to see those numbers, to be able to see that legend's larger, and it's just a simple change to the actual geometry of the plot, where we've added the theme here, and we've added the theme to the text, and there are many, many of these. So you can, we'll talk about it later on, but you can actually create your own themes very simply. For now, these are preset themes that someone somewhere made and then added them to the library, and we can now use them. So far so good? You guys understand that? All right, good. Let's go ahead and move on. So we're gonna go ahead and give this a challenge. And please don't be afraid to ask. It's always nice to try these challenges. Even if you fail, they will give you a lot of insight into how to work with what you're working with. So your challenge is to adapt the bar plot, the one that we made in the first challenge, okay? And if you need to go back for that, I can absolutely go up to show you the code for that so you can copy it over. So copy that code from the previous exercise, and you need to map the sex variable to the color fill of the bar chart. So on a bar chart, you notice that we had solid black. We want to split that into male and females. Change the scale of the color fill by providing the colors blue and orange manually. It says to see the API reference to find the appropriate function. I'm going to go ahead and show you a picture of what that's going to look like. Actually, I'm going to do that in a moment. You guys go ahead and try that challenge. I'm going to pull up a picture for you and to give you an idea of what you're looking for. Oh. John. Battery's about to die.
This battery here?
Yeah.
Oh, nice.
Yeah. Yeah. Totally. I mean, we'll learn. So, yeah, if you play this catch it. Yeah. We also stream all of these to our YouTube channel, so if you want to watch all of these lectures, we can make that available. Social Media Hacker Network has its own YouTube channel. They're all on there. Yes. There you go.
So, yeah. So just wanted to give you guys a representation. If you are attempting the challenge, awesome. This is what it will look like in the end if you want to get some information off of that. And I can also go up to the top and show you the actual code for the bar if you guys would like to give that a shot. So this is the starting space, or starting code rather, for the challenge that you're currently doing. If you want to copy that and then modify that, that will be your best chance at succeeding in the current challenge. And I'll scroll back to the other challenge once people have copied this code over. Good. Okay, good. Excellent. Okay. We're going to continue on a little bit since it looks like everyone has a chance to attempt it. Okay. Did anybody succeed in creating this? I would be very impressed because this was a bit of a trickier one. So if you didn't get it, don't worry. It was intended to be a bit tougher than usual. So let's go ahead and look at the code for it. We are going to do exactly what we've been doing all along, which is, is to give it the data survey is complete. We're going to give it a mapping of plot ID, and this is the trick. So remember how I told you to copy that code from the original challenge, not challenge number 1? That is the exact line that you used there as a mapping, and instead we're going to add a fill, so the actual filling of the bars is going to be divided up by sex. Next, you're going to keep the same thing. Of course, it's a bar chart, or bar graph rather, so you're going to keep that there. And then the last thing, which was the add-on, which is the scale, fill, manual, blue, and orange. This is the thing that you probably would have had to look up, which is why it was a bit trickier than usual, because we didn't really cover that. However, I think intuitively the concepts are pretty all right. So you fill it by the sex, and then you go ahead and make one of them blue and one of them orange, and you get this nice, beautiful graph right here, which is excellent because it does give us a fair bit of information. So we've got our regular bar graph as is, and then we've got them divided by blue being female and orange being male, and there's a count of each of them. So there's about 1,000 males right here, and then there's the rest of them that are females. And that gives us a lot of information that we might not otherwise have had graphically. So if you look at the rows of data, so of course you could probably rationalize that out by taking out a calculator and punching in 1 + 1 + 1 all the time, but I think that would probably take you quite a bit of time. So we're going to go back and continue with our code. Please let me know if you had any questions about that as well. That's probably something that's very helpful, is using bar graphs with fill. So I would suggest looking into that a little bit further if that is something that you need. Okay, so we've kind of been going in one direction, which is the kind of the beautifying of our graph, making it more visually appealing, make it easier to read. But what about the data itself? There are a number of ways to represent data and the distribution of data, as I'm sure all of us in this room are aware. This is just one. We've looked at points. Another one we looked at was bar graphs, but there are many, many others. So let's go ahead and look at different types of plotting distributions. Let's go ahead and just take P9. Oh, sorry. We'll start the code all over again. P9.ggplot. It's good exercise to do it over and over again because it does actually reinforce the concepts. So surveys complete. Okay. Let's go ahead and go to, come on now, mapping. That's not at all how you, let's try this again. Mapping equals p9.aesthetics, or AES. X is equal to species. That is not at all how you spell species. Try that again. Species ID. Okay, excellent. And the Y value is going to be weight. I'm going to try something different this time. Okay, let's go ahead and put that down there. Sorry, by the way, this can all be done in one line. I am doing this just because I enjoy having my code readable, just for your sake as well as mine. So next, we're going to do something that is fairly a simple change. So you remember how earlier we had the points, then we had bar graph. Well, let's try box plot and see what that returns, assuming it's not an error. All right. And this is a pretty intuitive change, I'm sure, as you guys can probably agree. Your first one was a plot, a point plot, and then it was a bar graph, and now if you take a peek at this, you'll get some very fascinating information. So as you know, the X value is the species as we defined it, the Y value is the Y-axis rather is the weight, and each of the species is given its own box plot in a graph-like form. Now this can be a really fascinating piece of information if you're trying to look at the data distribution of multiple species in a single graphical representation. And that is what that allows you to do. And of course, there are other types of plots that you can use, not just box plot. There are pretty much any kind of graph you can think of is probably, there's a package for it, and you can just simply add it with p9.geom underscore whatever that is. Check out the documentation if you need to find other types of plots. But for now, any questions on that? Seems pretty straightforward, pretty intuitive. Yeah, okay. So let's say, for instance, we want to merge two of our previous concepts together. So we've got this box plot distribution. It looks great. But if you want to take a peek at it, you don't really see, you don't get to see a lot of the data distribution. It's kind of just a box plot as per normal. So what if you wanted to merge this concept with the idea of transparency? Well, what you can do is you can add an alpha, or rather a lack of transparency, to anything that you want. So let's go ahead and add in a p9.geometry, or geom, and let's go with jitter, and we'll add an alpha to it of, let's say, 0.2. And then I also want to make the box plot alpha just 0. And let's go ahead and run this and see what happens. Apparently we're going to get an error. Type int.
So you're already going to box plot.
0 point.
Yeah. No, like, what is it you're setting to 0?
Oh, of course. Sorry. All right. So now we've got two different types of geometries into one graph, and we're going to see something very interesting. Now we have the original box plot in some weirder way from each of the species, and you can kind of see it here. It still exists in the underlying data, but now instead, for each species, we've got a multiple of data clusters that represent a whole new thing. Oh, sorry, I'm just going to try to get this perfectly right here. There we go. So as you can see, species ID down here, wait again, and each of these rows is still a box plot on the underlying, a box plot on the underlying column. And what's up? Oh, it's very fascinating, isn't it? So you can actually see each of these as a point all up and through here, and there are many, many points, but we set the alpha so low that when it starts to get darker, you can see that there's clustering there, and then when it's lighter, of course, there's less of a cluster, as you would normally see on a graph. But it's really interesting that you can combine multiple different types of geometries together to create new information. So not only do you have the box and whisker plots in this scenario, but you're also getting a whole other set of information on the same graph. So that can be very powerful too, depending on what you're looking for.
Can you make that more transparent, just because I'm curious?
More transparent? Yeah, absolutely.
The jitter.
Yeah, just make it alpha, maybe like 0.05, really, 0.5. Can't do 0.5? Why are you? There we go. Okay. It's quite fascinating.
So if you had a bunch of points plotting on top of each other, jitter's one way to take it on, and then alpha's one way to take it on, and sometimes you've just done so much sampling that both of them are not sufficient to actually show you the density of the meat. So that's...
Yeah, and I mean, this is incredibly low transparency, so, and you're still getting immense clusters here. Yeah. And you can go lower, of course, depending on what you need, but at some point, when you're so low, there's going to be data points that you're losing, and all you're going to see are like the biggest clusters. Of course, and if that's what you need, then that's what you need, but it's certainly one way, and you can add on, of course, if you keep adding on geometries over and over again, you're going to get to a point where there's too many of them on one graph and it becomes too complicated, but for this purpose, this works quite well. All right, let's go ahead and keep moving on into different types of things we can do. There's a challenge. This one is fairly doable, I believe. If we can go ahead and scroll down real quick. Okay. So distributions. Box plots are useful summaries, but hide the shape of the distribution, as we kind of just discussed a moment ago. For example, if there's a bimodal distribution, you wouldn't be able to see that with a box plot. It would look really weird. An alternative to box plot is the violin plot. For the record, I didn't even know this existed until I started looking at this lesson. It's a very interesting plot. It's also known as a beam plot, where the density of the points is drawn. So in many types of data, it's important to consider the scale of the observations, of course. For example, it may be worth changing the scale of the axes to better distribute the observations in the space of the plot. So you can go ahead and replace the box plot in this code. I'm going to show you real quick. I'll bring the code up in a moment, actually, once I finish this. You can change the box plot to a violin plot, which should be very intuitive to do because we've been doing it in multiple ways. You can represent the weight on the scale as log 10, or the y value rather. And then you can add color to the data points on your box plot when the sample was taken by plot ID. So that is the challenge, to do those three things. Check the class for plot ID by using factor within the AES or aesthetics mapping of the variable. Plotnine will handle the values as category values. So in that, like, you have the data at first. Let me put up the code just so you can have a visual of what I'm saying. So as you have your data, that's not going to change. Then you're mapping somewhere in here, something will change, and you're going to use the factor function in order to do what you need to do. And once you have done that, those three things, the challenge is complete. So right here is the challenge. And I'm going to pull up a actual representation, a picture for you, so you can see what it would look like when you succeed at the challenge. But for now, you can go ahead and give that a shot. And please do let me know if you're going to attempt this and you need to see the code, the code that we had gone through if you hadn't put it in. I'll go back to the code, that's not a problem at all. But for now, I'll leave that up there as is. If everyone wants to take a peek, anyone that's trying the challenge, this is kind of what it's going to look like at the end. Looks a little chaotic, but you're going to end up having your species ID as your x-axis and your weight as your y. And then these here inside are the violin plots. You can see those little diamond-like shapes. And then the clustering of the colors by species. So that's what a successful completion of the challenge is going to look like. If you guys want to give that a shot for a few minutes. And let me know if you need to see that again, or the code, or if you need to have the challenge in words up here, and I'll change it as needed. Okay, looks like everybody had a chance to take a shot at the challenge. This one was less tricky than the last one, but certainly it's still a challenge. So, did anybody manage to succeed in, or think that they succeeded in getting that chart that I had showed you? Sorry about that. Let me just pull up this. Anybody at all? No? Okay, that's fine. These are a bit tough. I understand that. So let's take a look at what the plot, or sorry, what the picture of it would actually look like. So it would be this beautiful chaos of a graph, and the code for it. I'm sure some of you got at least some of it. The alpha, don't worry about the alpha. That's not important. The geom violin. How many of you guys got that? I saw at least 3 or 4 of you that had succeeded in getting that part. The scale of y log 10. I saw almost all of you get that, and keeping the jitter. So pretty much everybody succeeded on this part. I think the only part that was a little bit difficult was this factor plot ID here. 30, sorry. So what we're doing is we're passing in the data, we're doing the mapping as per usual, species ID and weight, and then the color, the actual color we're going to use is going to be the factor of the plot ID. And this is a function that is found in ggplot. It's made for you, it can be used, and it does exactly, hold on. Yeah. I'm just trying to find an exact explanation as to what factoring does. Do you guys know what it is?
Yeah, so you've got basically a number, a column of numbers.
Yep.
And factor will take all the unique subset of that and categorize it.
Right.
As categories rather than numeric values.
Visually, that's what I thought happening, but I didn't know that that was it. Okay.
I'm surprised that it happens inside of string there because it's going straight to ggplot. It's not part of plotnine.
Yeah.
That's where I would have fallen down, I think.
I think so. This is local, not global, so I was confused. But yeah, so at least you guys are certainly understand. I know that a lot of you got all 3 of these perfectly, minus the alphas, and don't worry about that. That's just transparency. That's personal preference. Again, the color thing is also personal preference. But if you want to go ahead and either copy down this code or look at it, it's always, of course, available on the website. And if you guys need that, let me know. We'll write it down at the end. For now, this is how you would make a violin plot with a color factor of plot ID. So we're going to continue forward with that, unless there are any questions. I think most of you guys asked the questions while I was over there, so that's good. Let's go ahead and continue. As soon as I open this up. Okay, where are we now? All right. So now we're going to use, we're going to start combining older concepts that we worked with the newer plot line. So you guys remember we did data frames. Some of you were here, some of you weren't. When you could take the actual creation of a data frame. We're going to go back to those lessons, and if you need a refresher, we're going to do it along the way. So let's go ahead and continue on. So what we're going to do is we're going to calculate the number of counts per year for each species. In order to do that, we're going to group the data first by the species ID within each group. So let's go ahead and start that. Let's call it yearly counts. I think that's a pretty apt name. Is equal to surveys complete, which is the data frame that we, that's supposed to be an underscore, which is the data frame that we created way up at the beginning of all of this, as I'm sure you're aware of by now. And we're going to group by, that's not how you spell group by the year and the species ID. And then what we're going to do is we are going to, now that those 2 things are grouped, as you might remember, or maybe perhaps you don't, depending on how long ago it was you did this, we're also going to have species ID, and again, I cannot spell the word species for whatever reason, ID, and that is the parameter that we are going to count, so .count. And I'm actually going to go ahead and probably just put this down there. I think that should still work fine. Just so you can see it. So we're grouping by year and species ID, right? And then we're going to count by species ID. And what we're doing is we're taking our data frame that we created in this lesson, and we're going to make a new data frame by manipulating the data. All right, so that's all we're getting. We're getting back a data frame, sorry. And then what we'll do is we'll put yearly, that's not how you spell yearly, yearly counts, and we will run it, and we'll get a whole bunch of errors apparently. Doubt that that's a problem, but oh, it was a problem. Okay, my bad. So now what we've got is the year, and I guess remember the ellipses here, the 3 dots. That just means there's a whole bunch of data in between that the computer doesn't want to print out for efficiency's sake. So we've got 1977, 1978, et cetera, et cetera. We've got each of the species and also what their counts are. Now there are 2 major problems with what we're seeing right here. This is great data, and I'm sure that as a researcher you could absolutely use this. One of the problems is that this column has no heading. So we don't know what this number represents. We do because we put the code in, but anybody reading this might say, is it 181 species? Is it 181 species with a hind foot length of over a meter? I mean, that's a bit of a crazy one. We don't know what this is measuring. So that's going to have to change in order for us to move forward. And then the second problem is this is divided by year, then by species, and count. So we're not going to be able to manipulate this very easily with ggplot because we've got essentially 3 columns broken down into 2 different subsections, which is pretty to look at for us as humans, but computers, they're not really going to like this all that much because it's not very neat, it's not very road. So we can change that, and we can change that by doing something called resetting the index. So let's go ahead and put yearly counts, and we're going to make them equal to yearly counts dot reset index, which is very intuitive because that's what we're doing. We're resetting the index. And we're also going to put name equals counts. And what we've done is we've now effectively named that column that I was saying was one of the errors. And we've also made this data frame into something that's very computer friendly. So if you want to take a peek at what it returns, we now get 1977, this species, this count. 1977, this species, this count. And so on and so forth for many, many, many rows, 332 rows. So now we've got a data frame that, I mean, it looks a little less visually appealing to us as humans, that's fair, but to a computer, this is exactly what it needs to work with ggplot amongst other types of things. So we've got what we need, and what we're going to do is we're going to go ahead and plot that. So does everybody understand what we've done so far? Is there any questions? That was kind of a lot to throw at you, but essentially we took our original data frame, turned it into a new data frame, and that new data frame was a bit difficult for the computer to read, so we've kind of reorganized it by resetting the index to get this beautiful data frame here, which is very easily manipulated by computers. So we're going to go ahead and plot that. So if you guys want to start with your ggplot. And of course, next we're going to give it the data, as always, which in this case is going to be yearly counts, because we're using that new data frame that we just created, right? Next, we're going to map it. So that's not how you spell mapping. Mapping is equal to p9.aesthetics, or AES, x. So we're going to give it an x-axis of year. Why? Because that's one of our headers. And then we're going to also put a y value of, I'm sure you can guess it, counts. And we're going to go ahead and add in a geometry because we always need 3 things: data, aesthetics, or sorry, mapping / aesthetics, and a geometry. P9, that's not P9, P9 dot geometry. And let's do a line this time instead of a bar or a violin or a box plot. And we'll see this syntax error apparently because there's no comma here. Okay, and here's what we get. A very spiky graph. And this represents the counts of species right here, and this represents the years. Now, this is good. We can use this data, I'm sure, in many ways, but is it as good as we can get it? Very unlikely. What species are which, right? We have 24 species, and they're all coagulated into one line. So it's not giving us all the information that we could really use. Luckily, we're able to change that visualization, as we have done in the past many, many times today, by using one of the challenges that we had to, let me just go ahead and put that down there. All right, color, you guys might remember this, species ID. And so what we've done is, I'm just going to take that away. What we've done is now, well, we'll see it in a moment, but we've specified that we want to color by species ID. And since there are many species, I think there's 24 or more, we're going to get a different color for each that is randomly generated by the computer. Color is equal to, always a comma, eh? It's like my semicolon in Java. Now I've got one too little. Okay, excellent. So it looks a bit daunting, but certainly you can recognize immediately that this gives us way more information than we originally had in just a basic spiky line graph. So now we've got each of the species as a different color. We've got their years respectively by their counts, and we can look at that and we can say, oh, look, this species has been detected way more in 1985 than any other species, and then at the same time, you know, it's also on a low here as an example. It just gives you so much more data to work with instead of just clumping them all together. And that's done by one line, which is really great. So as a researcher, I'm sure you can imagine that this is a much better graphical representation of the data that we've presented the computer. And we can also make it better if we need to. And we will in just a moment. So is there any questions on that? You guys, it's pretty helpful stuff, right? Graphically? All right, so let's go ahead and move on. Please certainly let me know if there's any questions or if you need me to slow down. We're going to look at one of the last components of this lesson, which is called faceting. With any other library, plotnine has special techniques called faceting. And what it allows you to do is it essentially allows you to split one graph into 2 or 4 or 8 or as many as you need. Because this graph is great, and it does give us the information that we need. But could you imagine trying to read all 24 species on this one graph, how chaotic that might become? So what we would like to do is maybe split them by all species. Now granted, that would create something like 24 graphs, but at least they'd be much easier to read. So let's go ahead and work on that right now, which is called faceting. I'm just going to get back to where I was. Hold on a second. Okay, here we go. Perfect. So let's go ahead and change. Okay, let's go ahead and change these. So I'm just going to start a new one, actually. Let's just start a new one. It's easier. Sorry about that. Still working with a computer I'm not familiar with, but we'll get there. All right, so we're going to start by creating another ggplot right here, like this. We'll give it the data, which is, we're going to switch back from our other one to surveys complete, because this is all the data that is necessary to do this. Survey data is complete. Excellent. Mapping is equal to p9.aes aesthetics, and then of course we need to give it a x value, or an x-axis rather. Let's go with weight, comma, wrong place, and let's go with a y value, or axes, and let's call it hind foot length. Now you guys might remember this. This was the original graph that we had started working with at the beginning of all of this. And then we'll say color is equal to species ID, of course, because we want to make sure that each species has its own color to be able to ensure ease of reading. All right, and let's go ahead and add our geometry now. So p9.geom, let's say point, let's do a point. And just for the sake of actually visual representation, we'll put alpha equals 0.1. Now, of course, that's not necessary. As you guys have already seen, you don't need an alpha at all. But just to make it a little prettier for us to see, we will go ahead and run that. Of course. Oh, is something? Is it a comma? Of course it's a comma. All right. So this looks like just about almost exactly identical to the first graphs that we started making. You guys remember right at the beginning of this lesson. And we just got species ID by color, and on the bottom here we've got weight and hide foot length, and that's very excellent. But again, it's difficult to read. It's difficult to see what's going on. There's so many. Maybe as a comparison, side by side, this is excellent, but if you want individual pieces of data, that's going to be a bit difficult. So what we can do is we can add a facet wrap, as it were. So oops, go ahead. Can I get some continuity here? Cool. P9.facet wrap. That is absolutely not how you spell wrap. And we are going to wrap it by, let's say, sex. So now what we do is we get the graph split into two parts. So instead of it all being together, we have, this is the clusters for species on females, and this is the clusters for species on males. And we've got two separate graphs. This is very valuable data. We can absolutely use this. But what if you wanted something a little bit more? What if you wanted to see, let's say when you're doing a research, you've got multiple plots where you might see species, and you want to know which plot has the most occurrences of individual species. So we can wrap that as a plot ID instead of by sex, and you'll get what I was talking about earlier, which is instead of one graph, we've now got 24 graphs. And each of these represents a different plot where you might have set up detections or detection devices to be able to detect animals. And the same data is still represented here, but instead it's separated by plot. Now this can be exceptionally useful because you can also go back and do it, let's say, by species. So you can see where each species was as opposed to plots. So there's a number of things you can do with a facet wrap, and that's the geometry here is the facet wrap. It's very intuitive, it's quite easy to use, just the one line, and there's a bunch of other things, of course, you can do with it, which we can explore here in a moment. So as an example, we can also put, let's say you want to make a grid and see multiple aspects of it. So we can say facet underscore grid, which is another function. And of course, all of these are documented, so you don't have to worry about memorizing them or anything. You can always find them on Google whenever you need them. Year and sex. So this is a notation that's used. By the way, that's a tilde sign right here. So this is a notation that's used with the facet wrap function, and it allows you to specify your plots to be arranged in this particular notation. So I'll give you a visual representation of what that means in a moment when it loads. If it loads, apparently. Excellent, okay. So, oh, right, of course, I put it by species ID, my bad. So, that is absolutely chaotic. Did I mess something up? Oh, right, yes, of course. Okay, so this is, if you take a look at this graph, there's a lot of information going on here, and it's just not readable at all, right? So let's go ahead and add in on the top of this something really quickly. Let's go ahead and make another data frame that's a bit smaller. Because like I said, if you put too many things on it earlier, you can absolutely get to a point where there's too much going on. So let's say survey 2000, which is equal to surveys underscore complete. And then inside here, we're gonna make a new data frame. As you remember, we did this earlier, and of course, several times before in the past. We're going to make a new data frame, but we're only going to do it by year. And we're going to say, is that year is in the years 2000 and 2001. So now we're only going to get data that has 2000 and 2001, because as you can tell, this is a lot of years and a lot of data, and it's just too much to read. So we're going to isolate it down to something that's a bit easier. And then we are going to go ahead and run this We're also going to change, if you guys want following along, you want to change this from surveys complete to surveys 2000 because we've created a new data frame that we're working with, right? We're giving it new data. So if we run that, we're going to get an error apparently. Surveys complete is not defined. Is there a typo there somewhere?
There's no N
There's what, sorry?
in surveys complete here.
Oh, yeah. Couldn't see that from this angle. Thank you. Okay. Surveys 2000 is not defined. Yes, it is.
Survey 2000 versus surveys 2000.
Thank you. You got good at get sharp eyes. Thank you. All right. So, this is a bit better than the whatever we were looking at before. And as you can see, we got females and males, and they're split by, there's females here, males here, and they're split by species ID in the years 2000 and 2001 respectively. So this gives you the ability to manipulate data and visually represent it in whatever way you so choose. We've covered some of the basics, and I'm going to show one last thing before we go, because I think it's time now at 1 o'clock. Just about time. Perfect. So I'm going to scroll back down to the bottom, and I want to reiterate these key points, which is with just these two things in mind, you can absolutely use whatever we've learned today in a number of ways. First off, you're using data. You're giving it a data frame. You're going to use aesthetics, the X and the Y axes, and color, so you're making it aesthetically pleasing. And then the last thing you need is geometry, and the geometry is used with the plus operator, and you can do all sorts of things like relabel, make facets, themes, scales, different types of plots. And with just those 2 points, you can take all of the information in your data set, regardless of how large it is, and manipulate it to graphically represent what you need to see. Any questions before we end? All right, fantastic. So we're going to call it a day there. If you guys have not already, I believe it was passed around, there is a sign-up sheet at the back. It helps us with metrics, which we can then use to say, hey, people are showing up to these workshops, and we would love to continue doing them, and that gives us kind of the leverage to be able to do that. So please, if you wouldn't mind, sign that if you have not already. It definitely does help. And I will probably see you next time as a helper instead of an instructor. Thank you guys very much. I appreciate your time, and have a great day.
Also, don't forget, you will leave feedback on the post-it notes. One constructive thing that we can do better, and one thing that worked really well for you. We appreciate that. And if you stick them on to the door on your way out, we'll collect them anonymously and file them away in our brains.
Yes, please. There is food. Go eat it. It's there for you.